Okay, so we're back at this, and what my goal is now is I'm trying to keep my same rig going. I am simplifying things a little bit. I have my plan is to keep my Healy 2.0 out there, my I-2000. We're gonna always have those going, but I'm gonna have only one more turbine. Whatever's on this pole, that's gonna be my test rig. So just going to be the 3 turbines here. There will be 1 or 2 more in other similar projects, but I'm only going to have those 3 turbines fed into my assembly here. So now, in the past, what I've been using is the A30 controller to kind of keep all this stuff running. And I like this controller. It is easily the most versatile little voltage controller out there, and there's even an A30 Plus. Like, this thing has fully programmable start and stop voltages, and will let you sort out on and off voltages, when to turn on. It's a neat little controller. There's even an A30 Plus controller that has more options. What I don't like about it is that excuse me, I have to order it out of China, which the biggest problem I have with that is that it takes 2 or 3 weeks to get whenever I need one, which I'm trying to maintain a couple of them in packages here on standby for whenever I need one. But something that I've been experimenting with is some alternatives, and some of these are cheaper. Some of them, like this thing, is not really cheaper but more readily available. Whenever I order a new A30, it takes me a couple weeks to get it. If I order one of these things, this is a CD63L, I can get it in a couple of days. So now, trying to find ways to use these things. The drawback to these is that the load side of the relay is battery voltage. So it uses battery voltage to turn on and off, and the load side of the relay is also battery voltage. So you can't use this to turn on and off a higher voltage or lower voltage or an AC load. So less versatile, and it's also more finicky for voltage. The A30 controller can handle 80 volts, give or take a few, without too much problem. This one fries right at like 75. So not as versatile and a little weaker. I've actually got, I ordered several of these, burn up almost all of them, and I actually had to take the relays off of them so I could use the load side. I ran leads off of the load side to be able to run another load. So, not very versatile, does not deal well with a 48 volt circuit. If you have a messed up little spike that comes along and voltage shoots up, these things just cook. So maybe 12 volt or 24 volt circuit, be okay. And currently what I've got running is these things. These are HCW M634s, which is like that last one, only less versatile than that thing. The only reason why these things currently work is because I am using them on 24 volt circuits. I've got my 48 volt bank battery split up into halves, and one of these relays runs one and the other relay runs the other. Yeah, you can see my voltage spiked on, which side is that? That's this side. That's one of the downsides to doing this, is that these whenever the switch comes on and off, if it turns off for a second, it kills everything. But whenever it comes back on, it takes about 5 seconds for it to load up. And you see our voltage is up there over 70 volts. Takes a little while for that load to come back. Not good for the batteries, but I've never been known for being nice to my batteries. Alright, so back to these things. This is the same thing, except for, at least with the CD63L, you can set those up. You can program them for charge or discharge. These you can't. They are just straight It's a straight voltage. It's a battery charger. That's all it is. And it'll shut off at high voltage and turn back on at low voltage. What I've actually had to do is, do the same thing where I ran leads coming off of the load side. I took these relays off and ran leads from the load side of this to another set of relays, because that's another thing, only normally open. Had to run them to a set of normally closed relays so that whenever this is at high voltage, it actually turns my circuit on, and at low voltage turns it off, because I am discharging. Basically, whenever I get high voltage on the batteries, turns my inverters on. But at least has this up to where we are working. So that's that. I will say that because just for a general update on this, I've been using these little grid tie inverters with my turbines since the very beginning, and I've always used these cheap little batteries. These batteries are roughly 30 amp hour a piece, which gives me about 15 amp hour per battery that I can play with. And the only reason why I use them is that they're very cheap, and I do blow my batteries up. I really hate the idea of blowing up an expensive battery. So I use these cheap batteries, and what I have found is that they're good for about a year. It's very abusive on these batteries, which for what I'm doing, it is not that big a deal. But if you're actually trying to, get the highest efficiency out of your turbines as possible, got to use more batteries. Got to use bigger batteries, more amp hours. I need to actually break down and spend money on more expensive batteries, which I might have to do this year. So just want to do just a little bit of an update on that. We can see how they're running right now. The Healy is on top, I2000 on the bottom here. And it's blowing about 20, 25. Gusts are getting up close to 40. Lots of fun, lots of fun. Okay, that's that for now. Had to do at least one video this week showing what I was going through. So, thanks for watching, guys. Have a wonderful day.